Hello, this is our final trust project design analysis and discussion. I'm Travis Dudd.
I'm
My
Steven.
name's Aryak.
I'm Adam.
And my name's
All right.
Aryak.
All right. So when we were designing and building the truss, we used SolidWorks for our CAD and our drawings. SolidWorks was extremely helpful in helping solve geometries that would have been very difficult to do by hand. For our team, we were limited to 7 inches in height, and we chose 22.5 inches in length. And we really needed SolidWorks to figure out how long each member had to be and keep them all equal. In our design, it was important to us that we had a lot of surface area on our members by our gusset plates. So we went with 2x2 gusset plates, which were represented in our CAD and ultimately led us to having one of the highest loads. When designing and building our truss, we used many tools in the machine shop, including primarily the bandsaw, which we use to cut each member to length, and the disc sander to make sure each end of each member was the correct angle. When using the bandsaw, we used a guide at the exact angle that we measured from SolidWorks to make sure that each member not only was the correct size, but it was meeting it at the right angle. So we were more accurately um, be able to predict how much our load was. Um, we use laser cutting like every team for the gusset plates, which was helpful because it enabled us to make more than one iteration of our gusset plates, where we ultimately ended on our 2x2s.
And building the truss did not come with any challenges. When we put our truss vertically after putting on the first side of the gusset plates, it was very difficult to keep the members from touching, but we were able to overcome this by asking for help and putting shims in between the pieces of wood so that they didn't touch each other.
We also we applied our glue by hand on each link. It let us really make sure that we were spreading it evenly across each surface. We lasted a lot longer to shear than many other teams did, so I think we were pretty successful.
So come the day of the trust performance, the day of the testing, and we got around 828 pounds failing from shear stress on the glue, with a percent error of 146.27%, which is high. But the reason we believe is not having used the correct value for shear stress. As well, there are some errors in our building process. The point where it broke, joint B, it was not particularly aligned with the members that were on top. It was a little bit, popping out. So maybe it was receiving a lot more of the proportion of the force, and that could have affected the why I failed at B, not at E and at F as originally predicted. I think, yeah.
Okay, so for our comparison with different trusses, we looked at section 0301 and we saw that both Team 6 and Team 1 had the highest load. And in section 0400, 0401, Team 10 and Team 2 had the highest value for their load. And one of the themes that I saw when comparing these four trusses were each section had a hoe truss and a Warren truss that held the most load. And for the ones that had the least load, for section 0301, it was Team 11 and Team 12. And for section 0401, it was Team 11 and Team 7. And that we saw that Pratt trusses had the lowest amount. Now, looking at the strength to weight ratios for between the two sections, we saw that the one that had the highest strength to weight ratio was Beam Me Up, which was Team 10 for section 0401. which had a strength to weight ratio of 1,119.8. And the one that had the lowest strength to weight ratio was TaylorMade Truss, which was Team 8, which had a strength to weight ratio of 247.2 pounds. Not pounds, just 247.2. And then comparing our truss to Team 1 of Section 0401, we saw that they had applied load of 540, while we had applied load of 828, which meant that we had a higher load. But we also, both our trusses failed to glue shear. But one of the biggest things was the wood that was better on average was the red oak because it had the highest value in shear stress, normal stress, and buckling. And another big thing that we saw between the two sections were higher heights had higher applied load values. And trusses that had more members had a better distribution of the load when it came to higher applied loads.
Yeah, and also just to talk about why a reason I think their truss could have not might not have held as much as ours did, because even though they have the red oak wood, it's because it doesn't just from the picture, it doesn't seem like they actually built their truss to 7 inches tall, and also their gusset plates don't look like they cover as much surface area as ours did, so that makes them more vulnerable to shear. So yeah, for the lessons we learned in their trust project, so our team, we actually had pretty good time management throughout the project. We scheduled our appointment with the wood shop very early on. We had our truss built well in advance, and we were able to paint it and decorate it as a team, and that really helped alleviate the stress of the truss project could have caused. So we also like to point out that we should have allowed more time to design with the CAD because it was kind of a rush to get that all in the weekend that we had to submit our trust design report. And we also learned that we need to plan out exactly how we plan to build the truss, and that for example, like I mentioned earlier, the truss was difficult to keep the members from touching when we moved it vertically after gluing on the first side of the gusset plates. So if we had accounted for that and knowing that would happen before we actually were building the truss, it would have been a lot less stressful while we were building it. And then finally, of course, good team chemistry makes everything better. Is something we have learned from this because we've gotten along well throughout this project, and that really helped things be not stressful and move things along in a much more efficient way than it would have been otherwise. And in this image, you can see us here at a boba tea place grabbing some boba tea after class, and that was fun. Yeah.
Yeah, I think that last point was extremely evident in our final testing our trust. We all painted our faces green. I think having fun was definitely it's an important thing in every group project because it takes a lot of the stress off of having to work really hard. And if you have good team chemistry, the project's not only going to be a lot more fun, but if everyone's working together, and they're happy to work together, you're going to get a better end product. So it was a very fun project, and I really think our great team chemistry helped us succeed.
It's not just the people. I mean, it's not just the project. I learned a lot from Adam about the workshops and how to use the wood machines and lot. So I picked up a lot of new skills as well from it because he was enabling us to learn from him and whatnot. So, you also learn about yourself. You also learn stuff for yourself as well, not just for the project. It's really valuable.
Another big thing that I think that we learned through building this project was that theoretical calculations based off what we learned from ENES 102 don't exactly align with the actual results that happen from the testing. And I feel as if also mentioned in the course was that there's allowed error when it comes to design, even in the real world, when you actually have to design these big trusses, there's a certain amount of air that's allowed, and if it's way too high, that can cost hundreds to thousands of dollars in costs.
Yeah, I think that also like highlights the importance of like safety factors in industry. Like obviously, we were just doing this for a group project, but if we implemented a safety factor of like three or four of our initial like projection, we still would have been well under the load. So I mean, it definitely highlights the importance of building stuff to be a lot stronger than you need, especially bridges, and it'll definitely be something that we can all apply to our future classes and hopefully our futures.
Yeah, talking about future classes, this raises the concern about, we haven't calculated much for error. There's at some point they mentioned wood error and how each wood was kind of different than everything else. So we haven't gotten to those little bits of things yet. So it also opens up, this project opens up a lot more onto the future, what we're going to be getting into.
Yeah, I think you all said it well. I think we learned a lot from this project. We had good team chemistry. We got it done. I think we had a really cool truss. We held a lot of weight at 128 pounds. That's a lot. And yeah, I think this was a good experience overall.